Hey guys, so the next thing we got going on is this rate of change exploration. What I need you to do before we arrive to class next time is I need you to go on the internet and I need you to find two data points on something that's important to you. Now, what does that mean? For instance, for me, maybe I'll say the price of a can of Coke in 1965. Right now, I don't know, let's see. So, okay, find the price of a can of Coke in 1965 and then find the price of a can of Coke in some other year. Or maybe find President Barack Obama's approval rating many months ago and then his approval rating at some other point in time. We're just looking for two data points. Maybe how many wins the Yankees had on May 10th and how many wins the Yankees had on July 15th. I don't know. Two data points about something that interests you, whether it's having to do with money and finance or social media. You can talk about the number of Twitter users or Facebook users or tweets per minute or what have you. I just need you to find two data points of any variety. I think really interesting ones are having to do with inflation, how the price of things, of goods and services have changed over time. That's a good one. You can find the price of something in 1920 and 2000 or something like that. But that's kind of up to you. But we do need to come to class with those two data points. Okay, then what are we going to do? Then in class, what I would like you to do is to kind of answer these questions or kind of do these things. So over the period that you chose, I want to know what was the average rate at which that quantity was changing. So for instance, if the price of a can of Coke was only a nickel in 1960 and then it was $1 in the year 2000, how quickly was the price of a can of Coke changing? Or if President Barack Obama's approval rating was 54% in April, but only 52% in September, at what rate, percent per month, at what rate was that quantity changing? So whatever your quantity is, we're going to find that rate of change, usually per year or per week or per day or per hour or per something. Then on a set of axes, you can use Desmos for this. You can graph your two data points. And then either on Desmos, you might have to print it because it's really hard to do this on Desmos right now, draw a straight line between those two data points on your graph. And my question is, how does your answer to question one, how does that relate to the line that you just drew containing those 2 points? And then the question is, so you just drew a line between those 2 points. Do you think that's actually how your quantity behaved? If we're talking about the price of a can of Coke, do you think that it linearly increased from this price in 1960 to that price in 2000? Do we think that it kind of wavered or went up and down? Who knows? This is up to you. And then last but not least, if your quantity was to go in a straight line, if your quantity were to go in a straight line, make a prediction about what might happen in the future, maybe 10 years out or 20 years out, or who knows, just make a prediction. And as an extension, maybe you can come up with an equation to describe the relationship of the data points you chose, assuming that it grows linearly. I'm going to be circulating around to help out and answer questions and whatnot, but I wanted to give you this info now so you're ready to hit the ground running. These you're just going to do on a separate piece of paper. I'm going to want to collect it and at least see your work and discuss it with you, but you're kind of on your own here, right? I'm going to be walking around and helping out, but when we get to class, let's make it happen. All right, Benji, out.